The metallic bond 5.6. So far we have seen that a metal and a non-metal form an ionic bond. Two non-metals form covalent bonds. That just leaves metal with metal. Metal and metal form metallic bonds. How do you know if an element is a metal or a non-metal? Generally, as shown in the periodic table here, all elements to the left of the thick black line are the metals. All elements to the right of the line are the non-metals. The metallic bond is made up of just metals. Metals only have a very weak hold on their outer electrons. This explains why they easily lose electrons to non-metals. In the metallic bond, the outer electrons can easily move from metal atom to metal atom. Indeed, it is the attraction of the positive nucleus, full of positive protons, for the outer electrons on the neighbouring atoms which holds the metal atom together. The metallic bond is often described as a lattice of positive atoms surrounded by electrons. Another way to imagine it is to think of the loosely held electrons as the glue. Electrical conductivity is the ability to conduct electricity. Thermal conductivity is the ability to conduct heat. Metals are excellent electrical and thermal conductors. It is the free-moving electrons which allow for the quick transfer of heat and electricity. Heat makes the electrons vibrate more. As the electrons can easily move from atom to atom, they quickly pass on their vibrational energy, heat, to the next atom. The metallic bond is very strong, so metals have high melting and boiling points and are all solids at room temperature, with the exception of mercury. They are all good conductors of heat and electricity and are usually dense and hard. They are ductile, that means they can be stretched into wires. They are also malleable. Malleable means they can be hammered into different shapes. Think of the blacksmith at their anvil. Here we can see that metals form crystals. The picture shows gallium crystals. Gallium has an unusually low melting point of about 29 degrees centigrade. A metal atom will form a metallic bond with any other metal. A mixture of metals is called an alloy. Alloys can be made up of any amount of any metals. In pure metal, the atoms can easily slide over one another and bond to the next atom. This explains why metals don't break like ionic or giant covalent substances when you hammer them. It also explains how metals can be stretched into wires without breaking too easily. This property also makes pure metals very soft. Metals can be hardened by adding another metal. Metal atoms have different sizes, so the addition of a larger or smaller metal atom makes it difficult for the atoms to slide over each other. Pure gold often has other metals added to harden it for use in jewellery. Indeed, biting into a gold coin was once the test of its purity. You should now complete the multiple choice test, the metallic bond 5.6.